Hello everyone, welcome to day 1 of reviewing my Calc 2 notes. So we're beginning with section 6.2, which is exponential functions and their properties. And we're working with functions that have this form, f of x equals b raised to the power of x. And x could be just x or a function of x. And so let's jump into the different types of exponential functions. So there's three variations based on the value of b. So we have when b is greater than 1, the graph is gonna increase exponentially, and the limit as x approaches infinity for this type of graph you could see is gonna approach infinity, right? And then as you go to negative infinity, the limit approaches 0. When b is less than 1 or greater than 0, your graph will be decreasing. And so the limit as x approaches infinity is going to be 0. And then the limit as x approaches negative infinity is going to be infinity. And then here when b equals 1, 1 raised to the power of anything is always 1. So this is what it looks like for the graph when b is equal to 1. And then we have our natural exponential function. So that's when e is raised to the power of x. And we mostly work with this exponential function, this type for this section. And e is around 2.78, so that is greater than 1. So it's going to look, it's going to have the same kind of, I guess we could say, like behavior of this graph, right? And now here are some properties and laws of exponents. This you probably went through in algebra, and they bring it up again as a review. And this is important because it helps you break down different exponential functions in order to integrate or find the derivative. See, these are the formulas, rules for derivatives of natural and exponential functions. So the cool thing about the derivative of e to the x is it's always itself. The derivative of e to the power of u, which is some function of x, is itself times the derivative of this function here. And then the derivative of an exponential of base b, which is not e, which is any other number, positive value, raised to the power of x, is going to be itself times ln b. And now to integrate, we follow this rule. E to the power of f of x dx is equal to itself divided by the derivative of f of x, and don't forget, plus c. Okay, now let's do some examples. So if we're asked to find the derivative of this function y equals 3 times e to the power of 10 minus 2x, just a refresher, the derivative of some constant c times f of x is equal to that same constant times f prime of x. So that's what we're going to use here. Okay, so we have 3 times e to the 10 minus 10x. So this is y prime is going to be, so it's c times f of x. So this is our f of x here. And this, if you could tell, has the form e to the u. So if you remember, d of dx eu equals eu times the derivative of u. So we're going to keep bring down that constant. And then the derivative of this here, this function, is e to the u. So e to the u, e to the 10 minus 2x, times the derivative of u, which is this here. And what is the derivative of this? It is negative 2, right? So just to simplify, negative 2 times 6 is negative 6 times e to the 10 minus 2x, and that is your answer. And the next one here, I made a little mistake. This is supposed to be multiplication. That way we could practice the product rule. So if you remember the product rule, it's f prime g plus g prime f, which is the derivative. There's two functions here being multiplied, right? So the derivative of this is going to be the derivative of the first function, which is 10, times g, which is just the second function, which is e to the 5x, plus the derivative of the second function, which is e to the 5x, times 5, and then times f, which is 10x. Then simplifying, we get 10e to the 5x plus 5 times 10 is 50x e to the 5x. That's your answer there. All right, let's try two more problems. So here we're going to find the derivative of e to the power of tangent theta. So you could see it's e raised to a function of theta. So this is going to be, whenever we have e raised to the function, it's e raised to that function times the derivative of the function here, which is secant squared theta. And that's your answer. And then let's try one integration problem. So if you remember, the integral of e to the u is e to the u over u prime. So this here is our u, right? So then this is going to equal e to the 10x minus 4 times the derivative of u, which is 10. So this equals 10e to the power of 10x minus 4. And don't forget your plus c. And that's it. And thanks for watching. I'll see you all tomorrow.